Have you ever looked up at a massive airplane soaring across the sky and wondered, how does that giant machine stay in the air? Today, we're diving into the incredible science of airplane engines, the heart of flight, and discovering exactly how they generate the power needed to lift planes thousands of feet above the ground. 1. Understanding the basics of flight. Before we explore engines, it's important to understand the forces that make flight possible. Every airplane relies on four main forces: lift, thrust, drag, and weight. Lift is the upward force that keeps the plane in the sky. Thrust propels it forward, drag resists motion through the air, and weight is the downward force of gravity. Think of it like a delicate balance. Without enough thrust, a plane cannot overcome drag and gravity to move forward and rise into the air. Without lift generated by wings, even a plane with powerful engines would not be able to take off. Engines play a crucial role in this system. They convert fuel into motion, powering the plane forward and enabling the wings to create lift. Imagine trying to run with a heavy backpack. Your legs are like the wings trying to lift you, but without a push, you stay grounded. Airplane engines are that push, providing the enormous energy needed to lift thousands of tons into the sky. 2. The amazing science behind jet engines. Modern airplanes mostly use jet engines, which are marvels of physics and engineering. At a basic level, a jet engine operates in four main stages: intake, compression, combustion, and exhaust. Intake: air enters the front of the engine, pulled in by a large fan. Compression: the air is compressed tightly by multiple spinning blades, increasing its pressure and density. Combustion: fuel is injected into the compressed air and ignited. This produces a massive explosion of hot gases. Exhaust: the hot gases exit the engine at high speed, creating thrust, which propels the airplane forward. To put this into perspective, consider blowing up a balloon and releasing it. The air rushing out propels a balloon forward. Jet engines work on a similar principle, but with precision, incredible power, and control. A single Boeing 747 engine can produce over 50,000 pounds of thrust, enough to lift the entire plane, passengers, and cargo off the runway. Story example: imagine standing on a runway watching a massive plane take off. That roar you hear? That's not just noise. It's the engine converting fuel into raw energy, pushing the airplane forward, and letting it climb into the sky almost effortlessly. 3. Turbojet versus turbofan engines. Not all jet engines are the same. Turbojets were the earliest type of jet engine, designed primarily for speed. They are extremely fast but less fuel efficient and noisier. Today, turbofan engines are far more common, especially in commercial aviation. Turbofan engines combine the power of a jet engine with a large fan at the front. This fan moves a huge volume of air around the engine, producing extra thrust efficiently while reducing noise. This is why modern airliners are quieter, faster, and more fuel efficient than the first jets of the 1950s. Practical example: think of a hairdryer. The motor inside pushes hot air forward, but if you attach a large fan around it, the same motor can move much more air more efficiently. That's essentially how a turbofan works, on a massive, high-tech scale. 4. Engines and wings, working together to create lift. Engines don't just move planes forward, they enable wings to generate lift. As the plane accelerates, air flows over and under the wings. Faster airflow on top reduces pressure, while slower air underneath creates higher pressure. This pressure difference lifts the plane into the sky. Story example: during takeoff, pilots carefully increase engine power. Too little thrust, and the plane struggles to leave the ground. Too much, and it climbs too quickly, which can be dangerous. This delicate balance between engine power and wing design is pure physics in motion, turning mechanical energy into smooth, controlled flight. Without engines providing constant thrust, wings alone could never keep a plane airborne. It's the combination of engine power and aerodynamics that makes modern flight possible. 5. Afterburners in supersonic flight. Some engines, like those on fighter jets or supersonic aircraft, include afterburners. Afterburners inject extra fuel into the exhaust stream, creating a tremendous burst of thrust. This allows aircraft to reach speeds over Mach 2, twice the speed of sound. Story example: imagine a cheetah sprinting at full speed. That's the effect of afterburners on a jet. The acceleration is explosive and intense. While afterburners use enormous amounts of fuel, they demonstrate the raw potential of engine technology for extreme performance in military aviation. 6. Safety and reliability of engines. A-plane engines are designed with unmatched precision and redundancy. Every engine undergoes extensive testing for extreme temperatures, vibrations, bird strikes, and other potential hazards. Modern engines can operate for thousands of hours without failure, and airplanes are built to fly safely even if an engine fails mid-flight. Story example: commercial pilots rely on twin-engine planes that can safely continue flying if one engine shuts down. This redundancy is crucial. It's a testament to decades of engineering, research, and testing that ensures that passengers can travel thousands of miles safely, often without ever noticing the incredible complexity working silently beneath them. 7. The future of airplane engines. The future of aviation is even more exciting. Engineers are developing electric, hybrid, and plasma-based engines that are quieter, faster, and eco-friendly. Some designs aim to drastically reduce carbon emissions while maintaining incredible thrust. Concepts like ion propulsion and advanced electric fans can make supersonic commercial flights safe, sustainable, and more accessible than ever. Story example: imagine boarding a plane that hums quietly, leaves almost no carbon footprint, and propels you across continents in record time. The technology may sound futuristic, but engineers are actively testing these designs today. The sky is not the limit. It's a playground for the next generation of flight. Conclusion: A-plane engines are not just machines. They are wonders of engineering, physics, and innovation. They transform fuel into motion, power lift, manage thrust, and keep planes stable and safe thousands of feet above the ground. From turbojets to turbofans, from afterburners to electric engines, these machines make human flight possible and continue to push the boundaries of science. Next time you see a plane take off, remember the incredible science powering it. The spinning fans, roaring combustion chambers, and precise engineering that defies gravity every second. Airplane engines truly are the heart of flight, turning imagination into reality. If you enjoyed this journey into the science of flight, like, share, and subscribe for more amazing explanations. Let's explore the incredible world of science together, one fascinating topic at a time.